on realizing value for businesses through creation of highly scalable applications, specializing in event-driven and eventual consistency systems, and integration of large enterprise applications. More recently, he has been working on building out petabyte scale insights platform at low cost. And Ajinkya is a data scientist specializing in NLP and advanced conversational engine. He has contributed to computer vision projects in geospatial space. Over to the speakers. I think we need some time for the setup. I will hand it over to Anay Nayak for some details on the last session.
So I know this is usually one of the more difficult slots to be, which is like the second talk right after lunch. I'm glad to see that everyone's awake. Can I have a quick wave of hands just to make sure that everyone's here? With me? With me? Excellent. Try to keep this as interactive as possible. I'll share, both of us are going to be sharing a fair bit of information. Before that, let's quickly talk about why are we here, right? Like, so Ajinkya and I got together a couple of months ago now, and we were talking about trying to solve a very specific problem, right? Like I think me and a few other people in the office, we were talking about LLMs, how, for example, like all of you have probably seen, ChatGPT has taken the world by storm with the amount of context that it has. One of the challenges that we have is trying to, while it answers questions pretty well, how do you make sure that it is context bound? So if you've got a very specific domain, you want to try to sharpen that context and make sure the answers come from a certain area. How do you take care of some of these things? And so in doing so, we sort of embarked on a journey, right? In trying to build a RAG-based systems, we learned a fair few things in that journey. And what we're here to do is to try to summarize our learnings so that you could take that away. And hopefully when you show up on Monday back to work, or Sunday if you want to take your laptop and just play around with this stuff, the code, everything else should be available to you. You can use this as like a quick, as a starting point to actually be able to move on further, right? So we want to share some of these experiences. So one of the first things that we learned while going through this journey was how both of us kind of look at the world a bit more differently. And a quick summary of how what that is I'm a huge sort of PyCharm enthusiast, typical engineer, right? Love my IDE, love all of the shortcuts. And Ajinkya has ever so slightly different viewpoint where he thinks notebooks are amazing and he really can't believe that I'm using an IDE. So in doing so, though, we realized how the way we use tools is very, very different. It led us to talk about how we wanted to actually build this solution a bit more differently. So really quickly, let's talk about what are what the problem we are solving, and then how are we choosing the tools for today's task, right? So this is our 58th Dev Day. We've done this a few times already. Got a bunch of talks that we've recorded in the past as well, and all of this is available on YouTube. Quick show of hands, anyone who knows about that YouTube playlist which exists on the channel? Anyone who's seen it before? Anyone who doesn't work here? Okay. So here's what I need you to do. No, I'm not going to ask you to subscribe to the channel or something. But later in the talk, it will be useful if you can open up your phones. Not immediately, you can do this a bit later as well. Got a good 30-ish minutes before we need this. If you can open up your phone, go to the YouTube channel for Sahaj, look for a playlist called as DevDay, right? And you'll have a lot of the talks that we're going to be using in there. So what we thought we should do is, all these talks have a fair bit of information about a diverse set of topics that a bunch of Surgeries kind of focus on, right? So quite often as speakers, we get these questions that people will come and ask. For example, if there are specific questions about Kubernetes, usually Prashant's the one who will get that. There's a bunch of people out here in the crowd who are past speakers who've been on the stage. Each of them will get questions like this, right? So wouldn't it be useful if we kind of automated that, had a bot which could answer at least the first level of information, point them towards the resource which has all of this information so that people could watch the talk, or at least the section of the talk which is relevant, and then be able to move on, right? And then be able to go back and say, I need even more context, so I'll go talk to the speaker and I figure out the rest, right? So that's the first problem that we are trying to solve. Basically, given a domain, please be able to answer questions around that and be able to cite resources. So the principles for the tools, this part actually, interestingly, we realized that we looked at the world a bit differently, right, in terms of the tools that we are both used to. So we wanted to agree on a few things. We wanted to make sure that the tools we use will be easy to understand and use, because while both of us understand exactly what the other person does, our areas of expertise and the areas where we sort of have depth is a little bit different. I'm really, really comfortable, for example, in most environments to be able to build, deploy, test stuff really quickly. He'd be used to rapid experimentation, making sure models are built correctly, right? And so this slightly different viewpoint also meant that if one of us had to do a task on the other, like that the other's usually doing and be able to look at some of this, the tool set has to be easy to understand and easy to use. We wanted to make sure that there isn't a ridiculous amount of code to do this, so less boilerplate would be good. And more importantly, because we are experimenting, we wanted to make sure it's cheap to run, and as far as possible, it's free, right? So in this entire talk, all the tools we will use are going to use free tier tools. They're quite generous, and it's great for experimentation, so you can go back home and do it. The only thing that we're paying for is an OpenAI API license, right? And that's only a couple of dollars, so it's actually quite cheap to be able to use that as well, right? So with that, that's the only set of slides that we probably have. Oh, there's one more image that I would like to walk through, and then we can probably start with actually going through some of the code. So the first thing we're going to do is let's talk about, so for you to build this bot, you need information, right? If you don't have the data, you can't really do anything else. So the first thing we're going to do is, at a high level, just talk about the data processing flow, right? So you have a playlist available on YouTube that I just talked about. We need something which will really quickly convert, like look up YouTube to find from that playlist how many videos do you have. For each of those videos, we're going to look up something called as a transcript. Now, in case somebody's not heard the concept of transcripts, it's basically, you might know them as subtitles on the video or captions, if you've seen that YouTube button. They all mean roughly the same thing in this context. The way the transcript kind of looks is there's 3 fields for every transcript. You will have, sorry, excuse me. So you actually have 3 fields for every transcript. So you have the text, which is what you see up on screen. You have a start time, which is a number, which is basically number of seconds from the start of the video when this subtitle or transcript should be shown up on screen, and duration, so that the browser or whatever client is actually playing the video should know how long this video has to be shown up on screen. Now, this is a little bit of background from like YouTube in terms of how they structure their data, but it's important to know this because this information will be useful a bit later in terms of how we process this information as well. So what we're going to do is we're going to build a series of functions to be able to actually pull this information out. Now, normally you could just write one big script and run the entire thing, and it would work because the playlist has what, 10, 20, 50 videos. You'll process all of them in one shot and then be able to pick up all the transcripts. The challenge is though, that like every other YouTube playlist, this one gets updated all the time. Every month we do a new talk in Pune and most of our other offices, so every month or 2 you'll get a few videos which will come up, and you need to keep indexing new information because you have to make sure that all that is searchable. And so the way we do that is, going back to the image, each of these boxes it doesn't make just one long program. We've actually decided to make each of these an independently runnable script. The reason for that is if you're using something called as, basically we're using serverless functions to deploy all of these. In case you haven't heard them, you might also have sort of recognized this as like lambdas, if you've heard that term, right? So there's a bunch of serverless providers, AWS Lambda being one of the more popular ones. But like I said, there's dozens of them available out there. You could choose anything. We wanted to make sure that this runs every night or every hour, so that periodically you can keep making sure that updates get pulled. That's enough talking. Let's actually talk about code in terms of how we make this happen. So the first thing we'll do is, let's look at fetch transcripts because most of the scripts look similar. This is part of the code that we didn't want to actually build in front of you because it would be a bit boring. at least the last time when we did a dry run of this. So to avoid walking through sort of the entire code because it is fairly obvious, and I'll give you access to this entire repository. All of this is, well, is going to be open source at the end of this talk. So all of this will be available to you, but this is not the interesting part of the talk. So interesting part of the code at least. So what we do here is that we actually fetch the thing and actually push it into a database. But the interesting bit is to actually look at how this gets executed. So all we're doing is writing simple Python functions, as you can see here, making sure that there's an annotation on top. Now, the choice of tool that we've used in this case to be able to run this, normally you would use something like AWS Lambda if you're in the AWS space. Every major cloud provider has one. We thought of using a slightly different tool. Going back to our principles, we wanted this to be next to free or really, really cheap for us to be able to run this long term. So we had to, so we use something called as Modal. Now, the way Modal works is you add a dependency into your project. Just give me a second. So you add a dependency into, just doesn't want to open that file, I guess. So you want to add a dependency into your project where you add a dependency called Modal. This is also backed by a service called Modal.com. This is in no way a promotion or an endorsement of their service. It's just pretty easy for us to use, so we thought we should actually demonstrate a new tool. The website's Modal.com in case you want to check it out. The interesting bit is when you actually, yeah, I think it is. Was like a second ago. Yeah, it is. Cool. So, so instead of like talking about it, maybe it might just be useful for us to actually run the transcripts command and see actually how it works, right? Let me explain the command really quickly. I need poetry run to make sure the Python environment is managed. You can ignore that. Modal run and then the file name. That's all I'm doing in terms of being able to run it. The code, like you might have noticed, had an annotation on top which announced to the framework that this is a serverless function. Can you please take care of deployment? Which is kind of what it's doing right now. There's a step that you don't see because it usually builds an image as well. Since we've already done that, it's all cached. Now the reason why we're not doing that in front of you is it'll take a good 3 to 4 minutes, and we don't want to spend the time to necessarily do that. It runs the code really quickly, and whatever you've logged, it kind of shows. Unsurprisingly, it says that no new videos has been fetched because none of the talks from today have reached there just yet. But as they will, this thing will keep getting updated. Gave you a, so whenever it runs like a single job, which is not really a deployment, if I run it from local like this, it will give you a link which will give you the details of the application run. So clicking this really quickly allows you to look at all kinds of statistics in terms of utilization, usage, etc. Or you could just jump to something like logs. Now the logs aren't interesting in this case, but this information is useful a bit later. Right? You can also manage secrets, add storage if you want to. We'll talk about all of these features a bit later. But in summary, basically, if you run the script, it's going to make sure that all of this gets packaged, all of this gets deployed really quickly, and all of this is happening remotely, not on my machine. Now, so the reason why we ended up choosing this tool was in doing so. So when we set up the script, we wanted to make sure that this runs as a cron, right? In the long term, if we have a channel called, let's say, tech on the Sahaj Slack server, we wanted to make sure that the messages there get indexed. We can read those messages and actually pick up different bits. We can pick up different messages, the different videos that people post which are interesting, and we can start actually transcribing all of them as well, right? One of the bits I guess I forgot at the top was actually giving a demo of this bot, which would have been useful about 5 minutes ago. So we could, just to prove that this thing actually works. I've opened up a Slack window really quickly. If someone in the crowd wants to take a guess, wants to give me a question, I should ask it. If it's not a question that is from like the context, it won't answer it. But if someone wants to ask like a tech question, if you've done a talk in that area, it'll answer it. You can talk about probably Kubernetes. You can talk about, I think stable diffusion was one talk. We've done talks on, sorry? Sure, I can. So what I'm doing is I'm actually tagging the bot just so it knows it has to respond and it's not just a random message. And you'll get an answer in usually about 7 to 8 seconds you'll get an answer. And later we'll go into actually how you've built it and what are the different steps, but we wanted to give a quick demo of this and talk about some of the infrastructure and the deployments first, right? Cool. That I'm going to hand it over to Ajinkya so that he can talk about sort of how the actual QA pipeline is built, walk into details about that, unless there's a quick question. You can get it to do that. We can ask questions at the end as well, but let me just answer that. Sorry, repeat your question so that everyone can hear it and then also answer it. His question was, how do you know about citations? Actually, when he builds the pipeline, he will kind of show you a feature where you can add something to the metadata, which allows you to then use that later for the answers as well. We've not done that in the bot just yet. We've not built that as a feature. That's one of the future enhancements that we want to do. A couple of days later, you'll probably see that up on the code base. Though you won't be able to use the bot, but at least you can see it in the code, unless you do your own deployment, in which case you will, right? Okay, sorry, that was a little bit about the tooling. So far we've used something called as Modal to actually take care of the deployments. We've talked about how to actually run it from your console and do rapid iterations to actually kind of see what that feels like. Yes, we can do that. So let's maybe take a couple of minutes to walk through what it takes to actually set this up, right? So while it looks pretty simple, I mean it is, but let's talk about what it takes to actually make this happen, right? So you wrote a regular function which has whatever logic you wanted to. If you notice, there is something called a stub.function we're using. At the top of the code, we've created an object called a stub. Tried to keep the code clean, we've hidden this function away. Maybe go into some of the details around this. So most of the stub is pretty straightforward. Every application that you run, you want to give it a unique name so that you can look at the logs later and understand how it works. You can choose from any of the base images, or you can build one yourself as well. So in our case, we've chosen a pretty standard Debian image. We've installed a bunch of app dependencies. We didn't need it, but we did want to showcase that you could customize your image to whatever degree that you wanted to. And we've made sure that all of the poetry dependencies are installed. So normally I mean, it does support requirements files as well, which quite a few of you might be more used to. So if you manage your Python dependencies that way, then you can use that as well. Basically meaning if you manage the project, every time as a developer, you add a dependency to the project and you run the code, it will actually make sure that the image gets built correctly and it gets deployed. In case we want to demonstrate it, I can do that as well if somebody gives me a Python dependency that I should probably add to the project. PyTest, I guess, just not add that just yet. Now, demo gods withstanding, I will have enough internet to be able to download this relatively quickly. Run the same code, and you'll see the entire build happening, which might take a good half a minute. But hopefully it also makes sense that you don't have to, this is not the only tool that you can use. We also noticed there's something called as RayServe, which is another tool which looks very similar stylistically. The point is they've all been made with good abstractions so that you can focus on building your application, spend more time in doing that rather than actually focusing on exactly how you want to build the pipeline. So rapid iteration is kind of the idea. It does not build delta images. It will build everything from scratch, which means it will install all of them, and some of the dependencies it will take a bit of a time, a bit of a while to install as well. It'll run after that successfully and tell you the same thing, which is there are no more videos. Cool? Okay, while this runs, I will hand it over to Ajinkya to let him sort of demonstrate what building the actual pipeline looks like.
Hello, check. Am I audible? Let me order. Okay. Thanks, Karun. So I'll just go take 2 steps back, maybe, just to set up the context again. So till now in the whole day, what we have gone through is LLMs, why they exist, how they exist, and what all about LLMs almost, thanks to our all speakers. Then we went into how we can use it, how we can build applications. Then we talked about embeddings and stuff. Then we talked about vector database. Then Karthik and Sibin explained how the RAG pipeline works and how you can build applications. So in this, what we are trying to do is, with the use case that Karun now explained, we are going to demo how you can really quickly, with the less amount of code, with the tools that you are using, build a RAG application end-to-end and deploy it, and you already seen the demo how it looks. So the problem statement is simple. You are trying to build a QA system, which we are calling as a bot, which is deployed on the Slack. And you can do the question and answering. You can ask questions, you get the answer. Currently, it does not have any conversation history or stuff like that. It just gets the answer and, gets the question and gives the answer. Okay. Till now in this code walkthrough that Karun has given, what we have on the, I'm going to call the modal server where the current bot is deployed. What we have is on the local DB, we have fetched all the transcripts from the videos of the DevDay playlist. Okay? Till here we are clear, right? What we are trying to achieve. What I'm going to showcase right now is how we are going to build a QA pipeline on those transcripts. So for that, okay, let me show you a quick example of what that transcripts looks like. Into artifacts, if I go to transcript, okay. So this is one example of transcript. So I have taken pool of 3 video transcripts just for the demo. We have more than 50 in the actual DB. And this is how it looks. It's a long trail of text, basically, of a 1 hour or more than that long YouTube video. And we are going to create a small QA pipeline on build a DB on these 3 transcripts, or rather 3 videos. Okay. Okay, so you have already seen this. Let me hide that. Okay, you have already seen this image maybe in an earlier demo. This, what it basically shows is a standard RAG system. You have a custom knowledge base. So now I'll try to map our tools and our use case. These all block wins, okay? So this custom knowledge is nothing but our YouTube transcripts, which are sitting right now in those 3 artifact files. And in actual application, that is sitting on some DB, which is there on the modal server. Cool. Then we are going to use some embedding model to extract the embeddings. Then we are going to use one database, which is not a database that I mentioned. It is a vector database, inside which we are going to store those embeddings. And then we are going to retrieve it. And I think Karthik talked about how the semantic search works, similarity search and all of that. We are going to use similarity search to get those metrics or retrieve the metrics from the DB. Then we are going to, okay, it's prompt aside. Then we are going to create one prompt and we will put the question and the retrieve documents inside the prompt. And then we are eventually ask one LLM, which is nothing but, in this case, we are going to use OpenAI's LLM, the ChatGPT, the one we generally use. And then we get a response. And then this response, so basically this query, this is coming from, in our use case, coming from a Slack chatbot. it goes through this all process, and the response at the end you see is going to go back to the Slack. This is the whole system, okay? Okay, let's move ahead. So in overall, in a nutshell, what we are going to do is we are going to load the text. We are going to clean and create some chunks. Then we will create embeddings using some embedding model. Then we'll build the vector DB, then the LLM part where you basically augment and get the answer. And that concludes your RAG pipeline. So, okay, I think you have enough context. Let's go ahead. Okay, so quick disclaimer, I'm not going to live code it with the time constraints we have. I'm going to run the net cell by cell, and given the time frame, what we understood is maybe one of us will live code, and Karun being new to the coding, I thought he will take the opportunity to code, okay? I'm just kidding, okay? He's just great at coding. Maybe it's other way around. Okay, let's go ahead. So what we are going here is, okay, let me show you quickly what are the inputs and the tools. So these concludes our all inputs at once. We are going to use LangChain. Recently, this looks messy because recently LangChain guys decided that they will maybe split it into 3 libraries, one called as LangChain, LangChain Community, and LangChain Core. I don't know the reason, maybe something else. And then we are going to use Quadrant, which is our DB. Alternate options, I guess Karthik has one slide where you've seen the options, Pinecone, ChromaDB, and there are a lot. I'm going to use Quadrant. And in our application, we are actually using one service, which is Quadrant Cloud. I'll explain it in a bit. Yeah, so that's all. We are using Quadrant and LangChain. Those are the 2 dependencies for our whole pipeline. Okay, that's good. Okay, this is where I'm going to load the directory. So this is a directory loader. What it eventually does is it loads everything inside the directory. I'm just giving the path, which is to the artifacts, which is somewhere defined here. It will just load all the text files inside the directory. And what it creates is a document object. So if you have used LangChain, how the single object in the LangChain is defined is a document. Document class has few of the things. One is page content, which is nothing but actual text. Then you have metadata. I'll answer to your question later maybe. That's where we can add a lot more information which is not in the text, but if you want to provide some more context, maybe one example, let's say you are pulling the data from multiple locations and you want to have that information stored somewhere so that at the retrieval, maybe you can filter out it. Like maybe on the Slack I have seen, there are 4 channels, let's say, and you're building the bot which is going to respond to everything, but you want to maintain or have a constraint on the context that if something is asked from the tech channel, you should only respond to all the messages and playlists that are on the tech channel. So for those use cases, this is where it comes into. You can, while reading the data, you can add multiple things in the metadata, and at the retrieval, you can use it to filter it out. Okay, moving ahead. This is a small function. Again, I'm not really good at regex, so I just use ChatGPT. I guess everybody does that to come up with the regex. And what it does is basically it removes all the new lines and text which is not required. Okay, let me run it. It just simple. So it just cleaned it out, everything, whatever there in the text, which is not required, new lines and white spaces. Then we are going to talk about chunking. So if you remember that big image that Karthik showed, we load the data, then we divide it into a chunk. Here, so okay, I'll just again repeat, why do we need chunks? We can actually pull whole transcript inside it, right? But that doesn't serve the purpose because eventually what you're going to do is for this text change, you will get the embedding, put it into the vector DB. And what you're trusting upon in a simple logic is that simple vector embedding is representing the whole chunk. If you put the chunk, like let's say more than maybe 1,000 lines, then most probably that vector representation is going to miss out most of the details, okay? So that is one more thing, and again, as we are talking about the context, if you see the 2 parameters that recursive character splitter takes is chunk size and chunk overlap. This is where you define, and the rationale to what should be the chunk size and what should be the overlap is, as one of the next speaker, Venkatesh, talks about, is the context and the granularity. So if you put the chunk size very big, what you are basically doing is, for every single chunk, you are putting more context or more than what is required, but then you're losing on the granularity of it. And other way around, if you, let's say, put down, instead of 500, you put 50 as a text chunk. So basically just 50 words or maybe 50 characters, then the granularity is there in that text chunk, but then you're losing on the context. So that's the rationale behind what should be the chunk size and what should be overlap. That depends on what the use case and what kind of data you're working on. Okay, so let's just run it. And as you can see, the original transcript has more than almost 50,000 characters, and now we are divided it into the 500 chunks, okay? Chunks of a 500 length. Okay, let's come to the most important task, which is mostly, I think, ignored, but I would say this is the most important, or I would say bread and butter of the whole rack system. This is where the actual thing starts. Why I say that? Because if you remember the talks that I've given, or if you already know, that in the vector DB, you can actually, how do you put the data into the DB? You cannot put the text into DB, you have to convert it to the numerical. So this is where the magic happens, that you get the vector embeddings with some embedding model for every chunk, okay? Okay, we are just going ahead with this embedding model, which is provided by sentence transformer. Again, there are multiple aspects, which model to choose, why to choose, and all of it. Mostly, in my opinion, there are 2-3 things. One, the scale of the data or the scale of your whole system, what you want to do. Then second is the speed of it. If you go with the bigger model, your embedding model, while embedding the text, it will take a lot of time. So if your system is okay with it, then you can go ahead with the huge model, which will give you mostly more sophisticated embedding. But in our experimentation, what we experienced is, this is a good enough model. It is really fast, and it serves the purpose. Okay. Let's embed the data. So what I'm doing is, I'm getting one text chunk and asking the embedding model to create the embedding, okay? And okay, there is, I think, a typo. I should give it as a list. Otherwise, it will create the embedding for words, not the sentence. I'll explain it in a bit. So if you look at what I printed, the length of the text is basically how many number of characters you have. Is it audible? Okay, sorry. So the length of the text is 497 because we split it into 500. The sample embedding, it has given you one embedding of length 384. So where this 384 comes in, it is because the embedding model that you have chosen. Let's say even OpenAI provides you an embedding model, and it has an embedding length of, if I'm not wrong, 784 or something. Bigger embedding obviously have a maybe bigger, it's storing bigger semantic meaning, but we are okay with the 384. It works like a charm for our use case. Yeah, this is how the embedding actually looks. This is a long list of 384 numbers flattened in the list. This is how actual embedding looks. Okay, let's build a DB. So as I said, I'm going to go ahead with the quadrant. You have multiple options. Okay, I'm not going to the rationale of which DB to choose. Just moving it. So couple of things that it takes. Obviously text chunks, nothing but all the text that you want to put inside the vector DB. Then you have an embedding model that we have defined above. Then it is just a sample collection. Basically, you can, if compared with the normal DB, you can treat it as a table name for your database. Location, I'm currently putting in the memory. So there are 3 ways you can do it. You can actually provide a path and ask the, basically this quadrant method will create a vector database inside some directory. This is memory. What it means is it is building it in the memory. If I kill this script, it will go away. It's not a persistent database basically. And what we actually used in our code base is the quadrant cloud DB that I am talked about. So it will be, it is basically independent. Even if my modal server goes down or whatever happens there, my quadrant DB will be there, okay? And for that, just 2 lines of code. Instead of location, you just provide a URL to your quadrant and API key for it. And again, it's a freemium. It provides you 1 TB of memory for now, if I'm not wrong, and that is good enough. I mean, I can build a chatbot for all conversations on our channels. Okay. Yeah, so now we have basically built a vector DB. It has those many text chunks from all those 3 transcripts. And okay, now let's talk about retrieval. Here till this time we are not about retrieval. This is just building the DB. And in this cell, what I'm trying to do is the vector store, which is nothing but the quadrant DB. I'm querying it with just a sample query and asking it to provide me 4 relevant chunks, which are at the top. Okay. And if I run it, basically it's a long list, but it gives me, okay, I'm printing just first one, and it has a page content and metadata, as I talked about. Currently in the metadata, it takes just the transcript's name. You can put anything there. In our application, we have put YouTube video whole link as a metadata. And currently on the Slack, you're not getting the video name, but if in the next feature, if we return the source as well, with the response, you can actually have a clickable link, and you can click on it, and the video from where the answer has come, you can directly, it will directly start playing. So that's the feature that we are working on. Okay, I'll just really quickly move fast. Okay, this is where the generation comes in. I am just configuring the OpenAI model. This is the model name. It is similar to the ChatGPT, what we use. Okay, and let's talk about template. There are other sophisticated ways of coming with the template. What we have done is just experimentation, what works and what does not work. In my experience, if you go with the OpenAI, it actually really good with the templates. It might not even need this much longer template. It works, and if the context is not relevant, it also replies that the context is not appropriate, so I cannot answer the question. Okay. Okay, just switch to the actual pipeline. So till now, we have defined vector DB, we have defined which model to use, and we have defined template. So these are all 3 major things in your RAG. Retrieval, that is driven by quadrant. Augmentation is nothing but your prompt, and you put inside whatever you retrieve and question inside the prompt. I can just slowly show you. See, this is the prompt. So this is where you augment basically. This is your question. You give the question, query the DB, get the context, and put the context in the DOM. That is nothing but the augmentation, okay? And generation is nothing but the calling the ChatGPT endpoint, which is OpenAI endpoint. Okay, couple of things I'm providing here is a similarity. So if you look at this, retriever is a vector store, which is quadrant, which is working as a retriever. Similarity is the metric I'm giving. There are multiple other metrics that you can work with. Search quarks, basically k is equal to 5 means I am asking retriever to retrieve 5 relevant chunks, and those 5 and just listen to this, what I'm the whole explanation of it, so we'll get the whole idea of the pipeline. This stuff is actually what it does is stuffing all your retrieved text chunks together and putting it inside the prompt. So there are multiple chain types. If you go ahead with the, if I'm correct, there is something called a refine. What that will do is it will create a batches of the prompt. So if let's say you have 10 chunks as a retrieval, so that's k is equal to 10, let's say, and you don't want to have a longer prompt, then what you can do is you can maybe use some other chain type from the lang chain. What will it does is, it instead of calling it instead of putting it inside the one prompt and calling the OpenAI once, it will create a batch of it, then it will get the response, and then it will merge and give you the response. Okay, and rational to this, or the why would you do that, is basically the larger the prompt, the larger the number of tokens you are giving to the API endpoint, and there is a limit to that. So if you remember the LLM name, there is a 16K here. So what that means is the token limit is 16,000. With the ChatGPT 4, that is they're way ahead, but they're expensive as well. Okay. Okay, I'll just move ahead with the. Okay, let's try to query this thing. So this is our QA pipeline, which we have configured here. Okay, and if you query it, oops. So what it says is, I'm sorry, but I don't have enough information. Maybe let's start with the simpler one, and let's run it. Okay. Okay. So it has responded to perform multiple NLP. This is coming from Karthika's talk, because on those artifacts I have picked one which is on NLP talk, one which is on, I think, Kubernetes, and another one. So that's why it is able to respond, because those main information is there in our vector DB. Okay, let's. Yep. Okay. Let's look at the response from the QA pipeline. What it responds is a query, which is basically what we are run. Okay, this is older one. Let me run it again. Okay, so this is a query. Then you have result, which is nothing but your answer. Then you have documents, which is nothing but your 5 documents or 4 documents, which is very configured in the QA pipeline. And if I again go back and rerun the query for the one where we get the response that I cannot answer this. Why would it happen? Because, as I said, in our DB, I have 3 videos, one on the NLP, one on the Kubernetes. So it should answer, right? It should have been answered. The answer to your question is, we are saying that give me 5 relevant chunks. Those chunks, if you one step back, are 500 length text, which we have splitted. And when it responds, if we put the response, the answer is, I am sorry, I don't have enough information to answer this. And if you look at the page content, and if I just go to this, and if you look at, oops, sorry, let me do that again. Sorry. If you look at the source for all the documents is same. So what that means is, all the chunks are retrieved from Karthika's talk. And it should have retrieved at least 2 or 3 chunks, or at least 1 chunk from Kubernetes talk, but it couldn't. So how do you solve that? So I just want to really quickly show you this QA pipeline we have is, you can say, baseline rack. This is a standard implementation. What you can do more to improve it? There are multiple ways of doing it. One is a re-ranker. I'll just quickly show you how the re-ranker works. So what re-ranker, or an input for the re-ranker, is what you retrieve. Whatever is retrieved is retrieved from your actual DB or quadrant DB is the input for a re-ranker. And what that re-ranker does is exactly this. It gives the initial results is nothing but your quadrant DB retrieved output. It will re-rank it in the length, in the numbering from the relevancy. Like the first one is the most relevant, second is the second one, and moving it. So if now I'm going to do a small change. So if you look at it, I am using a re-ranker from a Cohere. Again, it's a freemium service, you can use it. There are multiple other sources from which you can use the re-ranker. The major change I'm trying to doing is in my base retriever, which is nothing but the quadrant DB's retriever, I am saying give me, instead of 5, give me 10 chunks. Okay? And as I said, obviously I can have those 10 chunks into my prompt, but then my prompt will be bigger. And if it doesn't work for 10, then I have to maybe put for 20 or 50. And then the prompt is this, so that's not a sustainable solution. So what we can do is add a re-ranker. Re-ranker, in simple sense, what it will do is, it will look at the question, it will look at the base retrieved chunks, and it will rank it according to the significance or the relevance to the question. And if now I built another QA pipeline, which is with re-ranker, and I am giving it the compression retriever, which is nothing but the re-ranker. So this is nothing but a QA pipeline with re-ranker, okay? And now if you look at it, it is able to respond to both the questions. In the first row, it is saying that multilingual information, so that's answer to our first question. First in the sense, the first part of the question. And what is Kubernetes? The second row is about what is Kubernetes. So basically, we retrieve 10 chunks, then we did re-ranker. We put at least one chunk from the Kubernetes relevance into the top 3, and then we created a prompt and generated it. Okay, I hope I am able to make the point. Okay, maybe I'll just stop here. I would have talked about Raga's test metrics, but I'll just skip it. The next talk, which is from Suman and Venkatesh, they're going to talk about the metrics, how you can evaluate your results and the retrieval. I'll just skip it right now. Yeah, so that concludes our QA pipelines. Just to again reiterate, this pipeline is what exactly is going to be used in the Slack. So when Slack asks something, now Karun will show you that we are going to call this pipeline to get the response, and then the response goes to the Slack. Okay, here, I know. Okay, I'll stop here. Thanks.
Good job, dude. Okay, cool. So for the last part, right? We're running a bit over time clearly, which is what the group in the back is having fun with. So the last part we're going to do is actually take the pipeline that we built, talk about how do you integrate with a Slack bot really quickly, do a deployment, and based on how much time we have, maybe a bunch of questions from you guys, and I would love to show some edge cases around what happens with the bot, what happens with how the data got ingested, and maybe a few other things as well, right? So, cool. So the bit that we want to get to is the Slack pipeline, so Slack server. So the way, a quick explanation of how the Slack server works. Every time we did sort of a @mention for the bot, what it did was, in the back we've already configured, you go to the Slack UI, you configure a callback URL, and wherever your application gets deployed, it sends events there. In our case, our base URL / events is where we got this call. Doesn't really matter what location you end up choosing, but basically the app handler, all we've done is we've taken the HTTP request, sent it to the app handler. Now the app handler does on the inside is a bunch of things. When you get a Slack request, you're supposed to validate the token, make sure the secrets are correct, etc. All that's taken care of for you. Slack gives a nice library for all of this called as Slack Bolt. So if you're using Slack Bolt, then you kind of get these things for free. You need to just forward the request there. In that case, what it'll do for you is you can start event handlers. If anyone's worked on any event handling sort of framework or type of application, you'd kind of know this. In this case, we are saying the event I want to respond to is app mention. The documentation has dozens of other types. Go read them, make your bot do whatever you want. So the interesting bits is, you know what, let's not go to like the entire use case. Let's actually try to build this out, right? If you didn't know anything about the bot, what is the first thing you do? Whenever you get an app mention, the sort of signature or the documentation says you'll get a body and you'll get something called a say, right? Does anyone know what's going to be in the body? Probably not. Some sort of dictionary is all it says, right? So let's just print it. Let's be lazy about this. I mean, I'd do debug if I could, but this application is going to be remotely deployed. So let's not do that. If someone were to try to take a guess as to what that say thing did, I'm going to guess it will say whatever you asked for on the channel. Quick way to validate? Let's actually try that out, right? Give me a message. Something PG, please, because this talk is being recorded and it's going to go up online. Typical programmer stuff. Let's say hello world then. No one's going to suggest anything. That's what we're going to do, right? Let's try to deploy this and see what that looks like. Same command, instead of modal run, I'm running modal deploy and changed obviously the file name really quickly. Let's iterate over this and see what that kind of looks like. Hopefully the image build completed last time. Didn't really check the logs. So it's not a thing. I'm not going to try to remove PyTest because if I do, it'll take another 2 minutes, time which we clearly don't have. So it deployed the application here. Don't worry, by the time this talk makes its way online, I will change the application URL and I will bring it down before a bunch of people online start calling this URL. The application is also deployed and you have the logs here. So what we can do is while we open the logs up really quickly, just go to applications, go to logs. The application was deployed, first created 7 days ago. We look at what looks like a pretty standard way to look at logs, ignore what's already happened. We'll go back to the chat, right? You want to ask a specific question? Someone give me a question that I can use, or I'll use the same one. If no one's done a talk on that, my friend. So his question was, is Linux overrated? No personal opinions. Sorry, sir. We're going to do that a bit later. Let's do what is Terraform maybe. Right? I'm sure we've done a Terraform talk. Now, it just says hello world. Why? Because that's what we asked it to do, right? Let's look at the logs really quickly. So we printed the body out. They get a token. All this gets validated on the inside. The interesting bit that I'm looking for is where is my question, right? So I do see what is Terraform in here, which is available as with the key text under the object event. So simply if I wanted the message, sorry, I'm going to go back to the code base at some point. I'm going to be like, message is body, what is it, event, I guess, and text, right? And now I need to call the pipeline, QA pipeline that he just created. Just happened to have a nice wrapper. Effectively, we've taken the entire wrapper that like he kind of demonstrated step by step. Instead of spending 5 minutes trying to copy paste code, we've already done that for you. We're going to take this message and let's be a bit lazy about it, I guess, and not format it in any way and just send it in directly. Let's see what happens. Ideally, what should happen, I guess, is, it needs a collection name as well. Right? Probably would be useful. We have a constant for that. So look through the YouTube collection where all the data has been pushed. Please search for the message, for whatever is the question that the users asked. Notice that I'm not doing any sort of pre-processing. So I've not removed the add Gyanasuchi when you ask that question. If you look at the original logs, the question had a user ID in here. So I'm not really filtering any of the questions, just literally sending the entire text, and it'll be able to process all of this. We'll have to redeploy, give it another 10-ish seconds. Hopefully the internet gods are with us. There we go. Sorry, we're going to go back here, try to ask the same question, and this time hopefully get a more realistic answer. Give it about 5 to 10 seconds, and you should see an answer. Terraform is a tool which allows you to create messages, create infrastructure, create and manage infrastructure. Read the whole text if you want to, that's fine. Now, a couple of edge cases, like a couple of things that we discovered we wanted to talk about really quickly, which I guess Slack doesn't do a great job at documenting, and some of the other techniques as well in the QA pipeline. This was like version 1 for us to do our bot. There's probably 2 use cases that I'd love to talk to you guys about. One is what happens when you, so there's a small piece here where we've said when we've deployed the app, we've said keep warm 1. Now what that means is if anyone's used serverless or done any sort of cluster deployment, you usually say at least keep 1 container live, right? The reason why you do this is because you want to make sure that the 1 container is always running and warm and available to respond to requests. Now when you don't do this, what would you expect, right? you'd say slow response times, right? That's what we expected too. So when we first built this version, we didn't actually do that. We didn't make sure the application was live. We saw a very interesting thing happen. So instead of me explaining what happens, let's actually demonstrate, right? I'll be boring. I'll ask the same question. The question doesn't really matter here. But you would expect to get the same answer right now, right? Because I've just changed the container count. What you will see is that the application will take a tad bit longer because cold start problem, which is expected. We'll keep waiting. And waiting. Hey, we have an answer. Everything looks fine, right? Oh, wait, what is this? Got a second answer. Interesting. And if you wait just a tad longer, you'll get a third answer as well. So what's happening in the case, Slack talks about this somewhere deep inside its documentation, which we never found, but we discovered this on production. If you take more than 3 seconds, it will resend the event to you because you didn't acknowledge the event, right? So it thinks that your app is down, so it sends it to you again. Unfortunately, it's not like our app ignored the event. It took the event, processed it. It just takes about, let's actually check the response times, right? So the first byte latency, in our case, is probably 9 seconds for the first one. Excuse me. Second container starts up and takes about 7 seconds. At some point, there'll be a third container as well, which will take 6, 7 seconds. Basically, there are no warm containers, so it is going to keep resending the message, and it times out after 3. Thankfully, it does not infinitely retry. We haven't found a way to configure this behavior just yet, but that's how it operates. Now, the trade-off that we made, basically, is to get the bot to work. Now, if we use this as an actual serverless function, we would have let it die. But if we did that, our costs would actually be lower, but our bot wouldn't really work because it would give you the same response repeatedly and no one would want to use it. Instead, what we did was we made sure that there's at least one container. You can configure this container count to be anything. You're actually going to pay a little bit more, but get the functionality that you need. Now, talking about cost, this is one of the things I think we've kind of not gone into some of the details about. Because cost is important, and at the top of the talk, we kind of promised you that you'd be able to run this for free, right? So let's actually look at that cost. So up here, you can kind of see how much we've been paying for our service deployment. We've been running this at this point for a week. Like you noticed, like about 7 days, today's the 7th day that it's running, about $1, $1.50, including all build costs. But the interesting thing is that you get $30 of free credit every month. So realistically, I don't think you're paying for the bot, right? Now, if you have more users, right now it's just me and Ajinkya using it, so we are not really sending simultaneous queries. But if you have more people, increase the count, container count, and that's a quick way to at least get off the block. There's other patterns as well if you read like that you can think of. The quickest solution I could think of is take the message, drop it into the queue, acknowledge the message, have the processing run in the background. But I'll be honest, we wanted to keep this free and we couldn't find a free provider who managed like a queue. You could also just use a database instead. There's N solutions. I'm sure you guys will think of them. But if you want to stick with that free plan mantra of ours and actually be able to run something, I think you can go a fair bit of distance with that. So that was one. The other check I wanted to do, if I'm running okay on time, is actually ask about one of the first dev days that we ever did in Pune, which interestingly, so let's actually try to find that question as well. I'll try to avoid wording this question myself. The question is effectively, I'm going to copy paste it. Sorry, I'm going to cheat a little bit, but what is the name of the speaker who talked about using machine learning for credit card fraud? And what we'll do is, we'll actually go to the bot. Oh, I should probably redeploy it after to avoid getting the same answer 3 times. And then we'll ask that question. And now, what we would expect. So most speakers, when they come on board, the first thing they would do is they would probably introduce themselves, right? So you'd expect the bot should be able to answer this correctly. So let's see if it can, right? The only way to know is to actually try. I'm going to paste the question in and ask. Let's find who the speaker talk was. Give it a few seconds. And you'll see that the speaker is, drum roll, thank you. I mean, I've got to wait for the API to respond, man. There's nothing I can do about it. Okay, if that doesn't work, don't worry, I have a backup. I've asked this question before. I'll just scroll to it. I really don't want to. Oh, there we go. So the name of the speaker is this guy named Colin, right? And my first message, and this is actually true, I can scroll up on the channel and show you the moment of panic that I had when I saw this, was me texting Ajinkya being like, hey, our bot is being super sus, dude. We need to debug what's actually happening. Because to the best of my knowledge, no one at Sahaj is named Colin. I don't know how many people noticed this in the talk at the top. Who's Colin? Exactly. So what happened was the transcript of the talk was, like, it mistranscribed it. We didn't do it manually, obviously, we're using an automated service. And so there will be mistakes like this happening all the time. So it thought my name is Colin, which I guess now you can start calling me Colin, and I have to respond to it because clearly YouTube seems to think so. But if mistakes like this happen in your source data, they will continue through it. Realistically, your choices at this point are, you could manually do transcripts, but that's going to take forever. That's not really a sustainable solution. Alternate solutions for this include, in the set of documents that we talked about, like he showed you metadata, we could have just added 2 or 3 text documents. One includes the talk title. We can add the author name in there, because realistically, you would usually make mistakes with names. That's a pretty common thing, especially with regional names such as India. YouTube might not catch our accent correctly and might not get our name. YouTube, in case you're listening, my name is Karun. That is spelled K-A-R-U-N. So the next time I do this talk, please, try to get it right. I don't know. All you can do is request, I guess, right? So, so that's one way. You can just add it explicitly, or you can request YouTube to get it right and just spell it out. The other bit that you can try to do is also add the description in there as well, because the description is usually a crisp summary. So if you ask it to summarize the talk as well, interestingly, it actually does a decent job, and we've not fed it our human summaries, but you guys already know how it summarizes well, right? So I'm not going to show you that. So we only have a couple of minutes, so I'll just take time really quickly to summarize. What we've seen is that you can take a bunch of these parts, use tools which are pretty easy to understand and get started with. Need next to close to no money other than OpenAPI, which I think charged us about $1 over the $1.50, barely. Actually, that's across the entire company, it charges $1. So individually, we probably spent a few cents. It is really, really cheap. You could swap these out if you wanted to. You could use a different LLM model. Cost would be higher because you would be hosting it yourself. But if you want to go cheap and you want to iterate really quickly, tools are available to be able to do this. Our database is free, so is our sort of hosting solution, right? So yeah, that's a quick summary. I'll just take questions if there are any. We have a couple of minutes, maybe we can take a few questions. What we can also do is maybe later in the day, if you want, we can take some time actually play around in case you guys have questions and you want to test the bot. We can actually throw questions at it and figure out what we want to change on the prompt or change something else in the code to actually make it answer better. Right?
Do we have questions?
Any questions for Ajinkya or me?
Any questions for Ajinkya?
Ajinkya, do you want to come up?
Yeah. Ajinkya, one question I have. So you increased number of chunks when you didn't get the answer first time. So does that really happen in real-time scenario? When you don't get answer, you have to increase the chunks and get the model trained. Is that the real scenario in case of large language models like 3.5 or 4 GPT?
Okay, so what I understand, I'll just rephrase
Sure.
maybe. What you're asking is where I showed that I did not get the response, where it says that it doesn't have a relevant context, so I cannot answer this question, right? I think if you implement RAG on a really sophisticated data set or something, on an actual use case, I think this is something you will face even, and I mean, mostly there will be cases where this will happen. One way I showed is there are multiple problems I can think of. One is the retrieval mechanism of yours is maybe not that robust. So what thing I showed is that's the case, right? When I retrieving, it retrieved only from the NLP talk. It did not retrieve anything from the Kubernetes talk. What ideally should have happened is I'm asking for 5 chunks. At least 1 chunk could have been there from the Kubernetes talk. So what we resolved is maybe a re-rankle will help you. Maybe we can deep dive into the retrieval mechanism itself. There are multiple ways you can do it. The retrieval mechanism maybe has using similarity. Maybe you can use some other metric. And there are ways you can write custom metrics of yours on the database. And another thing is the second case is maybe your data itself does not have any information about it. And maybe you will get the more correct answer, or maybe in the next talk when Suman and Venkatesh are going to talk about the context relevancy and all those metrics, you will get the answer about how you can judge whether the problem is in the prompt, the problem is in the question, or the problem is itself in the retrieval. So these kind of evaluations, at least at the preliminary level, you can do it with some metrics that maybe in the next talk they are going to introduce. Yeah. Does that answer your question? Okay.
So what you're trading off at that point is for higher accuracy, you're spending more time. As long as you're comfortable doing that, because all the parameters that he talked about, each of these requires more API calls and a wait time gets added. From sort of maintaining a production application perspective, you are going to take longer for the actual response. And as long as that trade-off works for you, I think you will get an answer. You're just adding a little bit of a delay.
Anything?
I guess from a service perspective, you make that trade-off to say how much time is okay.
Okay. Thanks, Ajinkya and Karun, for giving us, providing us practical considerations and challenges while building the Q&A bot.